Alright, Mr. Burfine here again with the last of this week's videos in solving what I'm coining as more complex trig equations, and something is going on rather than just looking at it, whether that be a u substitution or having to do some operation we're not as familiar with. This one, probably my favorite problem of this week because it ties so nicely into another concept that we've spent quite a bit of time on. So let's get right into it. So we want to find where 2 times cosine squared x equals cosine x plus 1. So basically we want to solve this equation and find what x values between 0 and 3 pi radians will make this equation equivalent to this one. And to do this, I'm just going to take a moment and look at this and see what is actually happening. I have some value squared, and keep in mind this is actually 2 times cosine of our argument squared equals cosine of our argument plus 1. And if I put this in parentheses as well, we can see that we have something squared equal to something, that same something, plus 1. So in this specific problem, we're going to substitute in a little different way in that I'm going to totally get rid of the trig equation and see what results in here. So I can use any variable we'd like. We can say u again because we've already been using that. Let's go ahead and do that. So let's say let u this time equal cosine of x. And what happens now is I have 2 times u squared is equal to u plus 1. And the result of this is actually a quadratic. And that's such a cool transition here that we went from a trig equation into a quadratic equation. So a refresher on solving quadratic equations, we want to set it equal to 0 and then go about solving it through various methods. So I want the leading coefficient to be positive, so I'm going to subtract u and subtract 1 from this right side to get it to equal to 0. So what that does is it equals 0 when I have 2u squared minus u plus 1. Now because 2 and 1 are both prime numbers, I'm going to try and factor this. We could use the quadratic formula, we could complete the square, that would be quite a stretch. We cannot square root this as it is in this form, but let's go ahead and factor it. So if I factor this, I'm just going to build it by thinking about how I produce these values. So I want 2u squared, so I'm going to put 2u here and u. Those are the only 2 values that will satisfy or make this squared. 1 is prime, so we're just going to put a 1 and 1. Now I know my signs. Oh, there's a typo there. One moment. This is minus 1 there. As I look at my signs, I know because this is minus 1, we're subtracting it, that my signs are opposite one another because it's a result of multiplying 2 values of different signs to get a negative. So I want to create a negative u. If I put a negative here, we're going to be multiplying u by negative 1 and then combining it with 2. That will result in positive 1. So I want to put a negative here and a positive there. So this is factored. So let's go ahead and solve it now. Now when we solve this, we factored it because I know if 2 values multiply to be 0, one of the 2 has to be 0. So we can say 2u plus 1 can equal 0. While solving this, subtract 1. 2u is negative 1, so u is negative 1/2. Or I can have u minus 1 equals 0. We'll add 1 to both sides. Or we can have a u value equal to 1. So I've solved this. We know this quadratic has solutions at negative 1/2 and has a solution at 1. It equals 0 at those points. So now if we back up and think about, well, what the heck did we actually do? Well, u is equal to cosine x. So now we're going to build 2 equations from here and say, well, I want u, which is cosine x. I want cosine of x. We're solving for x here, not u, so we have to take this additional step to be negative 1/2. Or I want cosine of x to be equivalent to 1. And now let's go back and look at what x values we're inputting here. We're inputting x values between 0 and 3 pi, so that's 1.5 revolutions around the unit circle. So if we go back to a prior problem, let me grab a unit circle real quick. Alright, ta-da, there it is. Went back to a previous problem and found it. So we want cosine of x equal negative 1/2. We want x values on the unit circle to be negative 1/2, or we want x values to be 1. So there are quite a few solutions here actually. And we're going from 0 to 3 pi. So we'll just do this by hand most likely. So I'm going to look at both of these simultaneously and just write out all my solutions so I don't have to worry about going around over and over. So x values where cosine is equal to -1/2 or 1. So every radian value in radians, every angle that produces -1/2 or 1. So 0 produces 1. So that's one of our solutions. So 0 radians is an answer. Now as we go around, we want cosine of 1 or cosine of -1/2. Cosine of -1/2 right here at x value. So 2 pi thirds is another solution. So 2 pi thirds. Continuing around, we want a cosine of 1. So we want to be to the right or -1/2. There's another one, 4 pi thirds. And then as we work our way around again, we're at 2 pi now, and we have a cosine of 1 again. So 2 pi. So what we want to do here is we can go all the way to 3 pi. So if we're at 2 pi here, 3 pi would be one more revolution. So it looks like the only value we're going to pick up again is this 2 pi thirds. But we want to add 2 pi to this because we're already one revolution around. Well, quickly, 2 pi is equal to 6 pi thirds. So we add 6 pi to 2 pi thirds to get 8 pi thirds. And that results in something that doesn't reduce, actually. I just wanted to check real quick. So there we have it all the way through. The solutions, the answers to this came from solving a quadratic by substituting, and it ends up our solutions are 0, 2 pi thirds, 4 pi thirds, 2 pi, and 8 pi thirds. I hope this video helped. I hope this week went okay for you. We'll see you in future videos and future discussions. Thanks.